Hello everyone. I wanted to take this opportunity to go give you a brief overview of Chapter 4. Again, this is just meant to be a brief overview, not comprehensive, but it gives you some insight into what we'll be talking about. And Chapter 4 focuses on insulation and air sealing. So the building envelope is an important term you should know. The building envelope, as we discussed before, separates the conditioned from the unconditioned space. The focus on the building envelope is relatively new in the last 40 or 50 years. And before then, like if you see a house was built in the 1950s or prior or thereabouts, the insulation, the building envelope is generally not as good, and codes have consistently progressed to the point that now that they're very every state is pretty adamant about having a strong building envelope. Older homes are going to have primarily fiberglass batt, and a lot of modern homes as well. It's really inexpensive and easy to install. But increasingly, spray foam is being used for, especially for high efficiency buildings, because it's good air sealing. Good for air sealing and for insulation. So anyway, they're sort of headed in that direction, I guess you could say, for high performance buildings. And there's emerging technologies that there's always some emerging technologies in the building construction field, and like structural insulated panels are relatively new. The aerogel insulation. So there are this is something that is always evolving. When you decide which type of insulation to use, you want to think about its performance, so basically the R value, if it has any air sealing value as well. How long is it going to last? And of course how much it's going to cost, and the quality of the insulation. There's different variables for each of these, like fiberglass batts are really cheap. Their performance is okay. They don't do any air sealing. But they do tend to last a long time. Whereas spray foam is rather expensive, but it's high R value per inch, really good air sealing. So you got to sort of do the cost-benefit analysis. So you can do, again, there's the structurally insulated insulation that we've talked about before with the structural insulated panels and the integrated concrete panels. You can do some bio-based insulation like straw bales as well. Again, you want to look at R value, but also vapor resistance is an important aspect, because moisture control is essential in a building, and some are good at moisture control, some aren't, and you got to make that consideration as well. And I'll discuss in this. There's actually a video that's posted in a PowerPoint. Also, I discuss how insulation works, and it basically prevents, remember, insulation prevents heat flow, not necessarily airflow. Air permeability, on the other hand, is different than insulation. You can have something that's a good insulator, like a fiberglass batt or blown-in cellulose. That's not a good air barrier, and so it's very permeable in terms of air and moisture. But not necessarily in terms of heat. So you got to really think about the difference between heat and moisture and airflow. They're all related, but they're not the same thing. Okay, so you want to look at the permeability of different materials. So vapor permeability is an important consideration as well. Everything breathes a little bit, aside from solid metal. Wood breathes, concrete breathes. If you're looking around you and there's drywall around you, that actually breathes as well. But drywall is considered either semi-impermeable or impermeable, depending on the type of paint that it has on it. Anyway, so there is vapor that diffuses through most surfaces, and you have to make that consideration when you look at your building envelope in a house, because again, moisture control is really important. Fire resistance is another one. So insulation has to be fire resistant, and so when you have like fiberglass batts, I mean, it's fiberglass, so it's not flammable. Whereas blown-in cellulose, which is really just chopped up wood fibers, they have to add a chemical to it, so it's fire resistant. And there's certain paints that are fire resistant as well. You have to consider the pest management. So a lot of insulation is infused with some pest management products like borate. But that's a consideration because these are usually in these, they're bordering unconditioned spaces, which could be a crawl space or a basement, and you want to keep the pests away. Pests can be really detrimental to a building. So there's all kinds of different ways you can apply insulation. You can blow it in, and there's actually some videos posted this week that shows you some of the different methods. Some of them are structural, some of them are boards, like the blue board or the pink board, or polyisocyanurate. So there's all kinds of different ones. Batt insulation, that's the least expensive one, the easiest one to install most of the time. That's the big rolls of fiberglass. And there's pros and cons. It's relatively cheap, but it's a decent insulator, but it's also not an air barrier, and it's not easy to install in every application. It is really important. I want to stress this bullet point at the bottom, that if you have a perfectly good insulation in a ceiling or a wall, and you're missing a spot that's only 5% of that surface, it can actually drop your total thermal performance by up to 50%. And again, there's different types of batt. The most common one is fiberglass, although mineral wool is used sometimes as well. Fiberglass batt, I think everyone knows what that is. You can do cotton batts. Okay, this is kind of an older insulation, not used as much. Wool, a nice natural material. Again, this is not super common. Blown-in insulation is nice because you can just fill in cavities, and there's a couple different methods of this. You can do it inside the wall, something that's called dense packing, or you can just blow it in what's called loose fill in ceiling. So you get fiberglass and cellulose. Those are your two most common. Cement-based, they don't really use that often. Foam, you can use, but it's not as common. There's your blown-in fiberglass. Okay. This is spray foam. Okay, so again, this is a really good air barrier and also a good insulating value. So this is high performance homes. You're going to have spray foam like this, and I posted a video this week on two-part foam. Cement based. Again, this is something that's not very common, but you will see that out there. You do need to have proper installation, and there are some standards for that, including with ResNet and HERS rating, which we went over in Chapter 1. Insulating boards, so EPS and XPS are pretty common, especially the XPS. If you've ever seen a blue board or a pink board at a hardware store or in a basement, they are used, especially the XPS. That's your blue board and pink board. It's good because it's moisture resistant. You can use it in damp areas like a basement, or it's good for foundation walls. But really high R value per inch, and also does some air sealing and water sealing as well. Then we got your structural insulation, so like ICFs and SIPs, straw bale. Again, straw bale is not very common, but ICFs, that's something that they use a lot in commercial construction in particular. We've gone over that before. Structural insulated panels, a little bit of a niche application, but it is done out there. If at all possible, you want to have continuous insulation around a building. So if you even have an old stick-built house, you can wrap that with insulation underneath the siding, and that'll prevent thermal bridging. Right, so here's straw bale construction. They actually use straw bale in the walls. So, you do want to look at, in terms of the impact of the materials, you want to look at the life cycle assessment. So, again, there's a lot of focus on green building in this course, and you really want to think about all of the life cycle impacts of everything that you use, including, is it a natural material? Is it used recycled material? Can you recycle it when it's done? Are there toxic chemicals in it? where was it manufactured. Like you have straw bale, you can do that locally. For example, if you have a cob wall, you can build that locally. But you want to think about, all of the life cycle costs of it as well. And, when you're calculating the actual economic cost, the direct economic cost, you want to look at things like the materials, how long it's going to, how easy it is to install, the sort of other costs, like is it difficult to get, and you want to look at the cumulative energy cost. So again, when we're building a green building or an efficient building, you want to look at the life cycle cost. So you may pay more upfront for a structural insulated panel, or advanced framing with extra insulation, but in the long term, you're going to save your energy costs. So you need to really do a robust calculation if you want to figure out the true benefit of these measures. And you want to look, when we look at the energy, it is important to look at the embodied energy, so how much energy it takes to manufacture the product, how much it takes to ship, and so forth. And air barrier, again, is something that prevents airflow. And so some insulation does provide an air barrier, most of it does not. So really just foam is the big one that provides air barriers, whereas pretty much all of the others do not. And there's different ways to excuse me, install an air barrier, like a house wrap. We talked about zip panels. That helps form an air barrier. If you've ever seen the Tyvek wrap around a house, that helps form an air barrier as well. But also just air sealing is really important. Drywall is a good air barrier. Put a couple coats of paint on it, especially. It's a really solid air barrier. All right, so there's your house wrap that I talked about, like the Tyvek. A thermal envelope, again, is that's the same thing as the building envelope. Okay. And that separates the conditioned from the unconditioned space. So the thermal envelope, you can sort of manipulate this a little bit, but it's basically where the insulation is. But you want to have the insulation and the air barrier continuous and in contact with each other. Okay, so the whole 6 sides of the building should have a fully continuous air barrier, a fully continuous thermal barrier as well, and so that way you don't have any leaks, and it maximizes your efficiency. So foundations can be a little bit tricky, but you do want to sometimes you want to bring the foundation, the basement within the thermal boundary. Sometimes you want to leave it outside. It just depends, and there's different ways to manipulate that. So walls are a really important part of the thermal envelope. Have to be nice, tightly sealed, well insulated. Try to eliminate all thermal breaks, all thermal bridges. Ceilings as well. And again, buildings need to have a completely air sealed and continuous thermal envelope as well. Okay, so there's different ways, different types of insulation you can apply. There's fiberglass batts. So there is something called facing. So an unfaced batt it doesn't have any of that paper. So if you've ever seen the fiberglass roll, and then it has paper on it, that's facing. And so what that does is provides a moisture barrier. There's blown-in fiberglass. Again, I do have a video, some of these in this week's lesson. So there's blown-in fiberglass. You can do mineral wool as well. Cellulose is basically recycled newspaper. Again, it's chemically treated, so it's fire resistant and pest resistant. So you can do this as a blown-in product, right? So you can blow it in. You wouldn't really normally blow it in the open wall, but I guess you can do it that way. And there's a video on dense packing in this week's folder as well. Cotton is nice because it's a natural material, fully recyclable, and a lot of it is from post-consumer. Again, wool is something that's very low embodied energy. It's a natural material, and it's it's naturally moisture and fire resistant. So there's different kinds of foam. You have low density and high density. Right, so closed cell foam, that's the stuff you see here on the wall. So it's good for, this is on, looks like on a foundation. Again, it's good moisture resistance, good air barrier, good insulator. There's different types of foam. You can get the 2-part foam or the little can of 1-part foam. When you're looking at how much insulation you should have in a building, this is the International Residential Code, which the Department of Energy actually have. This is in one of the videos this week as well, and it just shows you the R values that you should have in different areas of the country. Okay, there you go. IRC says the International Residential Code requirements. There are some hybrid systems like Flash and Batt, which basically you do spray foam, an inch or two of spray foam, and then you cover that with Batt. That kind of gives you the best of both worlds, because then you have air sealing, you have good insulation, but it's less expensive than just doing your spray foam, because that is pretty expensive. So your rigid foam insulation, again, XPS, that's the most common one. Polyiso is another one that's the highest R value per inch. And so you can use rigid foam for any number of applications, and I go over a few of them this week. So polyurethane foam is this 2-part foam. Again, there's a video on that this week. Cementitious insulation is less common, but this is something that provides a good pest, mold, and fire resistance. As you know, there are insulation requirements and there's different standards. And you want to get, Resnet does a really good job of providing a sort of cost-benefit analysis. And again, the Department of Energy gives you recommendations for how much insulation you should have in different climate zones. You also have to be really careful about installing insulation, because you can cause moisture problems. So like if you have insulation and then you put, let's say you have fiberglass batts, and on top of that you put a fiberglass batt that has facing. So you have something that, fiberglass batt that allows moisture through it, and then if on top of it there's something that doesn't allow moisture through it, you can actually get moisture issues in that lower layer. So you have to be really careful about that. And then again, we've talked about structurally integrated insulation a few times, like ICFs and SIPs. And this is great because this totally eliminates your thermal bridging, and it's also structural. Air sealing is really important. So all areas, you should minimize the airflow between the unconditioned and conditioned space. Again, I go over some of these principles in this week's lesson as well. A good way to do that in like a finished attic is if you do this spray foam, because again, that provides good air sealing and insulation. And so the thermal envelope, again, you want to have a complete thermal envelope, so all the way around your conditioned space you should have a full complete layer of insulation and a full complete layer of air barrier all the way around. And there are some challenges in different types of building, like over garages and things like bay windows and dormers and so forth. Okay, so I'm actually going to stop it there. Hopefully that gives you some sense of the content from this week's chapter.